That could be the difference between "we saw it coming" and "wait, how is it already here?" Because hypersonic weapons don't play by the old rules. They fly at least Mach 5, roughly a mile per second, and unlike classic ballistic missiles, they can maneuver on the way to the target. Fast, low, unpredictable, and built to show up late when you have the least time to react. And here's the scary part. The hardest part of missile defense isn't the interceptor. It's the tracking. You can't shoot what you can't continuously see. And that's exactly why the US Space Force's Space Development Agency, SDA, just made a move worth about $3.5 billion to put a brand new kind of missile tracking nervous system in orbit. This is not one big satellite that does everything. This is a swarm, a mesh, a space-based web, and half of it is built for something that sounds small but changes everything: fire control quality tracking. In a second, I'll explain what that phrase really means, and why it's the difference between warning and actually stopping hypersonic threats. Alright, to understand why this SDA move is such a big deal, we have to start with the problem. Hypersonics create. For decades, missile defense was built around the ballistic missile. A ballistic missile launches, goes way up on a big arc, and then drops back down. That path is predictable, and that makes it easier to detect and track. But hypersonic weapons, especially hypersonic glide vehicles, do something nastier. They can ride a booster up, then glide at lower altitudes and maneuver. And that low and turning combo is brutal for traditional sensors, because ground-based radar has a simple limitation. It's line of sight. If something is flying low, the curvature of the Earth hides it until it's much closer. So, hypersonics can stay out of radar view longer, and your first solid track can happen late in the flight when the clock is already almost out. Minimal time, minimal margin. Now you might think, so just use satellites, and the US already does. The problem is, legacy missile warning satellites were optimized for a different job. They're great at spotting the bright flash of a launch. But seeing a launch is not the same as holding a precise track on a dimmer, maneuvering. Target as it flies. And for missile defense, precision is the whole game, because if your track is fuzzy, your interceptor is guessing. So now we've got the setup. A new class of weapons that fly fast, low, and unpredictable, and an old sensor architecture that wasn't built for persistent, high-precision tracking of those kinds of targets. And this is where SDA steps in. I think that's enough suspense, so let's reveal the move. On December 19, 2025, SDA announced 4 agreements worth about $3.5 billion total to build 72 tracking layer satellites for Tranche 3, part of the Proliferated Warfighter Space Architecture, or PWSA-72, and they're slated to launch in fiscal year 2029. Wow, factor number 1! These 72 satellites are organized across 8 orbital planes. That matters because it's not about having one amazing camera, it's about always having eyes in the right place at the right time. In SDA's own words, this tranche is meant to achieve near-continuous global coverage for missile warning and tracking. Near-continuous, global coverage. That is the holy grail for hypersonic tracking. But the next wow factor is even bigger, and it hides in 2 acronyms. SDA is splitting these satellites into 2 categories, MW/MT, missile warning and missile tracking, and MWTD, missile warning, tracking, and defense. That last word, defense, is where the story gets serious, because warning and tracking are not the same as defense-grade tracking. Here's the simplest way to think about it. Missile warning is something launched. Missile tracking is, here's where it is as it flies. Missile defense tracking is, here's where it is with enough accuracy right now for an interceptor to use. That's fire control quality. And SDA says half of this Tranche 3 constellation will support advanced missile defense missions, meaning half of these satellites are designed to help close the kill chain against advanced threats. If you've never heard kill chain before, it's the full sequence. Detect, track, target, engage, break any link, and the chain fails. SDA is saying Tranche 3, once integrated with their transport layer, boosts the coverage and accuracy needed to close that chain against advanced adversary threats. Translation: this is built so the sensor data can move fast enough and be accurate enough to guide a defensive response. So what are they actually putting on these satellites? Infrared sensors, heat-sensing eyes, optical communication terminals. laser links, and high-capacity radios to send data down to Earth with backups for command and control. That sounds like hardware trivia, but it's the blueprint. Because SDA isn't building a satellite, they're building a network, a sensor layer, plus a data layer. Tracking layer sees the threat. Transport layer moves the data, fast. And fast matters because with hypersonics, seconds aren't nice to have. Seconds are the whole thing. So the PWSA is designed like a low-latency mesh network in orbit. The satellites don't just talk down to Earth, they talk to each other in space with lasers, so the track can move across the constellation and drop into the right place, right when it's needed. Now here's the question that always comes up. Even if you have 72 satellites, how does that help track a hypersonic target that's maneuvering while the satellites themselves are flying at orbital speeds? This is the part most people miss. The trick isn't one satellite tracking the whole flight. The trick is custody, continuous custody. One satellite detects, another picks it up as the geometry changes, another refines the track, and the network hands off that track like a relay race. That's how you get persistence. And this is where the wide field of view versus medium field of view idea matters. Wide field sensors provide broad coverage and cueing. Basically, I see something. Look here. Medium field of view sensors are more sensitive and more precise, so they can hold a higher quality track. Working in tandem with SDA's wide field approach is the Missile Defense Agency's Hypersonic and Ballistic Tracking Space Sensor, HBTSS, designed for that more sensitive, medium field of view tracking. Wide field cues, medium field refines, and the refined track becomes usable targeting data for interceptors. In fact, in 2025, a test demonstrated that HBTSS data could detect, track, and perform a simulated engagement of a maneuvering hypersonic target. That's not a promise, that's a proof point. Now, the way SDA awarded these contracts tells you a lot about the strategy. Instead of handing everything to one megaprime, SDA split the tranche across 4 teams. Each team delivers and operates 18 satellites. Lockheed Martin, 18 MWTD satellites, up to $1.1 billion. Rocket Lab, 18 MWTD satellites, up to $805 million. Northrop Grumman, 18 megawatt per megaton satellites, up to $764 million. L3, Harris, 18 megawatt per megaton satellites, up to $843 million. 2 suppliers building the missile defense-capable payloads, and 2 suppliers building the warning and tracking payloads. And Rocket Lab being in this lineup is honestly a sign of the times, because it shows how space defense is shifting toward faster, more commercial style. Production. The old model was a few huge satellites, exquisite, slow, and expensive. The new model is many smaller satellites, competitive vendors, and refreshes about every 2 years. SDA literally calls this spiral development. Field a capability, learn from it, upgrade it, launch the next generation, because the threat isn't standing still. And here's a wow factor people don't talk about enough: resilience. If your missile warning depends on a small number of satellites and an adversary can target those satellites, that's a single point of failure. But if your architecture is proliferated, dozens, then hundreds of satellites, resilience is baked in. You can lose some and still have coverage. You can upgrade without waiting for a block replacement. And when you combine that with a laser-linked transport layer, you don't just have more sensors. You have a space-based system that can push tactical data quickly to the edge. We're already watching this architecture get built in layers. For example, the Space Force has described Tranche 1 as 154 operational space vehicles, 126 transport layer satellites, and 28 tracking layer satellites equipped with optical, communications terminals, and K-band capability. Tranche 1 is the foundation, Tranche 2 expands, and Tranche 3, this $3.5 billion move, is the jump toward near-continuous global coverage and real missile defense-grade tracking from proliferated LEO. Now, back to the title, Changed Space Defense Forever. Is that clickbait? A little. But the shift is real, because this isn't just more satellites. This is a new philosophy for solving the sensor problem, from big, few, strategic warning to proliferated, networked, tactical tracking and targeting. And when it works the way it's designed to work, it turns space into the first layer of the defensive stack, not the last warning bell, the first layer. And that changes the equation for hypersonic threats, because hypersonics rely on two advantages: they reduce warning time, and they complicate tracking. So if you restore warning time with global coverage, and you restore track quality with fire control sensors, and you move that track through a low-latency mesh network, you're attacking hypersonics at the exact points they try to exploit. Now here's the last cliffhanger. Once you've built the nervous system, you start thinking about reflexes, new interceptors, new engagement concepts. Maybe one day space-based defenses that react faster than anything on the ground ever could. But none of that matters if you can't see the threat clearly and continuously. And Tranche 3 is SDA putting a massive bet on solving that first. 72 satellites, 8 orbital planes, laser links, near continuous global coverage, and fire control quality tracks. So here's the question I want to leave you with. If space becomes the first line of missile defense, what do you think the next line looks like? Drop your thoughts in the comments. And if you want more breakdowns like this, where we decode what just happened in the aerospace and defense tech, subscribe, because the next chapter of this story is going to get even crazier. See you next time.